Hello everyone. Our topic for today is empirical and chemical formula or molecular formula. What do you mean by this? Let's start. The empirical formula is the simplest mole ratio between atoms. Simplest mole ratio. Look at this table closely. In the first column you have many of empirical formulas and here the molecular formulas. If you can see that CH can be an empirical formula for many molecular formulas like this. C2H2, C3H3, C4H4. If we divide by 2 here, y divide by 3 here, divide by 4, CH is going to be the CH is the empirical formula for all of these. Look at this, P4O10. How I can find the simplest ratio here is by dividing by 2, so well, I get P2O5. So in many questions, some questions actually, when they give you the molecular formula, it's so easy to find the empirical formulas, just you have to find the simplest ratio by dividing. But are all the questions the same? No. Actually, you have to do some calculations in many questions about empirical formula. Let's see how. To find the empirical formula, I just summarized what you have to do in 2 steps. You have to now find number of moles. And in most of the questions, they give you the masses of these atoms. Once you were given the masses, it's so easily to find number of moles. The only thing you have to do is to use the relationship that we have learned before, which is mass over molar mass. So this is what you have to do. Finding the number of moles. The second step is to divide. Divide over what? The smaller number. What smaller number? The number of moles that you found in the previous step. Things will be clearly more understandable when we do this example together. A gas sample contains only nitrogen and oxygen. This is the question what tells you. It contains only nitrogen and oxygen. If 54 grams of the sample contains 14 grams of nitrogen, what is the empirical formula of the gas? So I will organize my thoughts now and see what steps I have to start to find the empirical formula. I will follow these steps, find the moles and divide over the smallest number. So how I can find the moles here? I was given masses. First, I have nitrogen and oxygen. These are the 2 elements I have here. So what I was given is the 14 grams of nitrogen. So I will write it here. This is the mass, 14 grams. What about the mass of oxygen? How I can find it? The question told me that it's 54 grams of the sample and it's only contain oxygen and nitrogen. If the nitrogen is 14, so what is left is for oxygen. So what I have to do here is just to find the mass, which is 54 minus 14, it's going to be 40 grams of oxygen. So now I know the mass of oxygen here. So the mass of oxygen is 40. Okay, these are the masses. The first step, the mass for each atom. Now I have to find the number of moles. Moles, how I can find them? 14, okay, over the molar mass. What is the molar mass of nitrogen? Where I can find it? In the periodic table, over 14 equals 1. And here, 40 over 16, and it's going to equal 2.5. Let's do the second step, which is divide over the smallest number. What is the smallest number here? Divide by 1, divide by 1. So the ratio is 1 to 2.5. But you have to know something. Fractions are not allowed. I have to make this a whole number. It's the simplest whole number ratio. No fractions allowed in the formula. I can't write, for example, in O2.5. I can't write like this. So what I have to do is to multiply this to become a whole number. I have to multiply it by 2, but I can't do it for one side. I have to do it for both sides. So I will multiply all this by 2. So what is the ratio will come? 2 to 5. This is the ratio, 2 to 5. So now I know the ratio. The empirical formula, 2 to 5. So I will write it here. N2O5. This is the empirical formula. This is the empirical formula. I just followed the steps and I found the empirical formula is N2O5. Okay, let's move now to the next topic. Molecular formula. Molecular formula is the chemical formula that shows the actual number. It's not the simplest ratio, the actual number of atoms in this formula. What calculations, our questions and calculations you have to calculate regarding the molecular formula? They ask you about the molecular formula, giving some information about the empirical formula, and then from the empirical formula, you can find the molecular formula. Sometimes, if you were given the empirical formula itself, it's easily to find the molecular formula by simple calculations. But the questions sometimes need you to find first the empirical formula. You need to know that you have to find the empirical formula first, then calculate the molecular formula. Let's see this question together. How to find the molecular formula for the empirical formula? You have to memorize this first. The molecular formula is a number times empirical formula. The molecular formula is a number times empirical formula. What is the number? What do you mean by number? The number is the molar mass over molar mass of the empirical formula. When you find this value, it's going to be the number that you have to use here and multiply it by empirical formula. Let's do the question. It's going to be easier to understand. A hydrocarbon propylene has a mass of 42. Okay, and contains hydrogen and carbon, 14. So we have carbon and hydrogen. These are two elements. 14.3% of hydrogen. So it means this is the mass of hydrogen. So the mass, I can't find the molecular formula before finding the empirical formula. So that's why I'm repeating the steps of finding the empirical formula here. The mass of carbon is 85.7 and the mass of hydrogen is 14.3. Okay, next what I have to find? Moles. Okay, how I can find moles? 85.7 divided by 12 and 14.3 divided by 1 is the molar mass of hydrogen. So the answer here equals, here it's 14.3 because it's divided by 1, and here it's about 7. We rounded it, the answer will be 7 point something. You can round it to 7. So now the second step, divide by the smallest number. So I'll divide by 7, I'll divide by 7. So the ratio here, let's continue here. 7 by 7, 1, 2. 14 divided by 7, it's about approximately 2. So what is the empirical formula? Empirical formula, I will write it here. What is the empirical formula? It's CH2. Here is the empirical formula. Okay, but I didn't finish yet. After finding the empirical formula, I have to calculate the molecular formula. So if I go back here to calculate the empirical formula, times the empirical formula, I found CH2. So now, how I can find this number? I will use this formula. The molar mass of what? The compound that was given. They told me in the question that it has a mass of 42, the whole compound. So it's 42 divided by the mass of the empirical formula. What is the mass of empirical formula? Molar mass of empirical formula. How we can find it? 12 plus 2 times 1 equals 14. So 42 divided by 14, and if you're going to do, it's going to be 3. This is the number. What I have to do now is multiply by 3. So if I multiply the molecular formula by 3, it's going to be C3H6. This is the molecular formula. So let's organize what we did. Empirical formula first. We follow the steps. And this is what this was the ratio, 1 to 2. So CH2. And then we multiply the number that we calculated from here, 3 times CH2. And this is the molecular formula. When you practice, you'll find it easier, of course. Okay, so please practice and do this question by yourself. And see you next time. Good luck.